All right, so what we're going to focus on in section 2 is 2 parts. The first part's going to be multiplying out factors, and then on Monday we're going to reverse that and we're going to review factoring and solving. And I wanted to break this into 2 parts because it's been a long time since we did some multiplying. So what you have here on the first problem is x plus 1 times x plus 1 times x plus 2. We have 3 things multiplied. You're going to have to decide to put one of them on the shelf, so to speak. And so I'm going to take this first x plus 1, and I'm not going to do anything with it. And I'm just going to rewrite it down here as x plus 1. Now, what I am going to do is I'm going to FOIL the back part. So x times x is x squared. Outside, x times 2 is 2x. Inside, 1 times x is 1x. And last, 1 times 2 is 2. Now I combine my like terms. I still bring my x plus 1 down. And I have x squared plus 3x plus 2. Herein ends step 1. We have multiplied 2 of the binomials together, and we have a remaining binomial that we have to deal with. Now we go to step 2. Step 2 would mean we take the x and we multiply it times each part. So that's going to give us x cubed. The middle one's going to give us 3x squared. And the last one's going to give us 2x. We're halfway there. Finally, we're going to multiply the 1 times each of these. 1 times x squared, and I want you to watch where I write this. What's 1 times x squared? 1x squared, right? I'm going to create what I call an x squared column. And so I'm going to write 1x squared right there. Because later, when I combine my like terms, it's going to be in a vertical column and be easy for me. Second, 1 times 3x is 3x, and I put that in the x column. And then lastly, 1 times 2 is 2. So let's add these up. Whoops, disappeared on us. Let's add these up. That gives us x cubed, 4x squared, 5x, and 2. Review from yesterday. How many terms are there? How many? What's the number?
4.
4. So what do we call that? What kind of polynomial? Just a polynomial. All right? Little more precise thing. What do we call this term right here in terms of its degree? Yeah, Owen, it's the quadratic term. What is the linear term? 5x. What is the degree of the whole polynomial? Cubic. Or as a number, 3. So just a little review from yesterday. But this is our answer right there. Some people like that linear vertical method. Some people don't. If you want to stretch it out and do the stretch out thing and combine your like terms that way, you can also do it that way. All right. Now, little challenge. Everyone take your drawboard ball and see if you can bounce it in such a way you hit 3 corners at once. Or you can just try to get rid of it by moving it out of the way. Can anyone get three bumpers? You got 3 bumpers? Very nice. Consider yourself the drawboard king. Sean Reed, the drawboard king. You did it? Oh, all right. Reigning king.
3 hit the corner and then one.
It's got to hit 3 walls.
I did it again.
All right. You guys are truly amazing. You guys should show your parents this. This is what you did in class. No, don't do that. All right. Moving on. Here we go. I'm going to bring down the x minus 1. Just throwing it down there, and then I'm going to multiply the rest. Danielle, Owen, and Michaela, this row. Take it away.
X squared.
Good.
Plus 4x.
Good.
Plus 3x.
Good.
Plus 12.
Good. All right. Bring down the x minus 1. Combine like terms. 7x. Cool math students cross their 7s. Now we have a trinomial times a binomial. Now let's multiply the trinomial. Here we go. X times x squared is x cubed. X times 7x is 7x squared. X times 12 is 12x. Now the submarine side, negative 1x squared, negative 7x, negative 12. This is the horizontal method. It stretches it out wider. The benefit is it stretches it out. The drawback is it's not lined up. Whichever method you want to use, it doesn't really matter. Either way, we still have x cubed, we still have 6x squared, we still have 5x, and we still have minus 12. Curious, by a show of hands, who likes that vertical method better? Anybody? A couple of us? Who likes the horizontal method? All right, so use whichever one you like better. Doesn't matter. I just wanted to show both of them to you to have a kind of ability to go either direction. Trivia question, reviewing for the quiz next week. Tell me the quadratic term on the second problem. 6x squared. Good, Zach. The quadratic term is 6x squared. Tell me the linear term. 5x. What is the constant? Is it 12 or negative 12?
Negative.
Negative 12. Good. What is the degree of the entire polynomial? Third degree, called cubic. Okay. All right, moving on. Second part, it says write each expression as a polynomial standard form. It looks like it's very similar, but the reason I brought these two problems in here is they each present a different piece that we haven't considered before. What does it mean to be x minus 4 cubed? Does that just mean x cubed minus 4 cubed? No. It means x minus 4 times x minus 4 times x minus 4. So write that out. X minus 4 times x minus 4 times x minus 4. I'm going to put this first one on the shelf, so to speak, and not deal with it. And I'm going to FOIL the back two. X times x is x squared. X times negative 4x is negative 4x. Negative 4 times x is another negative 4x. And negative 4 times negative 4 is plus 16. I combine my like terms. Sorry, Owen, I cut you off.
Why'd you put it in brackets?
Just because I'm trying to differentiate with all these parentheses. It's another grouping symbol. It still means multiplication. I know we used them for matrices, but it also means multiplication. So it's just a way to differentiate a little bit so you know what I'm doing, so to speak. All right. Now we have x minus 4 times the trinomial. Layla, Anna, and Megan, can you do this line? X times x squared, x cubed, x times 8x, okay, negative 8x squared, x times 16, 16x. Okay, now let's do the other one. Negative 4 times x squared, negative 4x squared. Negative 4 times negative 8x. Good. Positive 32x. And negative 8 times 16. Sorry, negative 4 times 16. My fault. Negative 64. All right, let's add them up. X cubed, negative 12x squared, positive 48x, minus 64. I will tell you I used the vertical method for the sole reason of I was going to run out of room horizontally. So I was just like, I'm going vertical here. That was the only reason I went vertical. No other reason. All right. This is going to test a couple people's memory. Do you remember what terms like x minus 5 and x plus 5 are called? Who wants to play hangman? Go.
A.
A is the first guess.
B.
I.
Guys.
A.
E.
E is the second guess. F is the third guess. I is the fourth guess.
C.
C is the fifth guess.
B.
B.
Yes.
Julia. Conjugates. Very good. Conjugates. Conjugates are special binomials that are exactly the same except for a plus and a minus. And so conjugates are wonderful things that we have. And when you multiply conjugates together, nice things happen. So let's take these two conjugates here, 3x minus 5 and 3x plus 5, and multiply them together. And that gives us 9x squared plus 15x minus 15x minus 25. And then you can't forget the x plus 2 at the back. What's nice about conjugates? Yeah, the middle terms cancel out. Good morning, Jack.
Morning.
That gives me 9x squared minus 25 with the x plus 2 at the back end. So remember, conjugates are nice, and because that's the case, my goal on this first one is to choose to multiply the conjugates together first, because I know those middle terms are going to drop out. So if you ever bump into a problem with conjugates, do those first. It just makes life easier, and that's why I put this example on here, to give you an illustration of that. All right, let's FOIL the remaining stuff. 9x squared times x is 9x cubed. 9x squared times 2 is 18x squared. Negative 25 times x is negative 25x. And negative 25 times 2 is how much? Negative 50. Is that in standard form?
Yeah.
Yes. All right. Now, the instructions at the top said classify our results by terms and degrees. So let's go back to the first one. What is the degree of this left-hand polynomial? Cubic. All right. And it is a what kind of polynomial? Just a polynomial. So it's a cubic polynomial. Is this one also cubic? Yes. Is it also a polynomial? Does anyone remember the fancy name for fourth degree? Quartic. Nice, Danielle. Quartic. Yeah. All right. Well, that being said, any questions?